Okay, hello. So welcome back, kids. For today, we're going to talk about water resources, and it's more than just about the H2O. Okay, so our PowerPoint's being troublesome. Okay, so we know that only a quarter of our Earth is land mass, and that's three-fourths of it, nearing three-fourths of it, is actually made up of water. Now, in that percentage, we actually only have around 3% in fresh water, and that only less than 1% of it is actually accessible to be made into drinking water or into other uses that we can do with it. Now, if you will look at this graph right here, we can only actually access around 0.62% of it, and that most of the fresh water is actually stored in your glaciers, right? So again, the rest of the water is stored deep in ice caps and glaciers that are actually continuously melting and fusing with your groundwater, rather with your salt water, with your oceans, and that a lot of it is actually also in deep underground locations that we cannot access as of now. And that we actually have the water cycle to thank for whatever supply that we have. So without the water cycle, we actually won't have enough supply of fresh water. Now, we usually get our water from the three possible sources of groundwater, surface water, and dams and reservoirs. Okay, I blocked my face. Now, in this case, we'll first talk about groundwater. Now, when we talk about groundwater, it's the water, the precipitation that seeps into the soil, the gravel, and the rock. And that we usually draw this using pumping mechanisms or through wells. Now, usually, we have these layers of permeable rock where water is stored. Those are usually called aquifers. It's a new word you learned right there. You're welcome. Now, in any case, usually they're in these aquifers. They usually have characteristics of porosity and permeability. So if it's porous, porosity talks about how porous it is, how much space there is between them, and that of course we have permeability. Now in this case, the more porous, the more permeable a rock layer is, the more water can be stored into it. So in turn, they have a direct relationship. My dogs are right there. You can hear them, right? Now, aside from that, we usually get these groundwater sources via wells and pumps, and that usually we bore a hole into the zone of saturation. The zone of saturation is the part of the aquifers where there is the most water. So there's a lot of water in the zone of saturation. However, because of continuous pumping, this particular level, the water level, the water table in the aquifers tend to experience a drawdown. So drawdown, the water level decreases, leading to a cone of depression. Mental health is important, okay? Mental health is important. Now, in this case here, we have as an example of your aquifer, or in this case, a water table. So they are a bit synonymous, but not really. Now, in any case, because of the continuous pumping, if you would follow my pointer right there, because of excessive pumping, excessive use, and excessive withdrawal of this water, there is a cone of depression that is being experienced. So, in any sense, the best idea would be to shift to the use of a different well. So, excessive use of water leads to cone of depression. Even water gets really down. Now, in this case, because of this, we have a lot of fresh water underground than there is in all the world's rivers and lakes. However, do take note that these sources, these aquifers, these groundwater sources, they tend to recharge very, very slowly. Yes. Now, there are disadvantages when we constantly use groundwater sources. One example is overpumping. Because of the overpumping, lower water levels, therefore more resources, more cash, more kaching that should be used to dig deeper to reach these aquifers. However, of course, not every human is made equal, so therefore, poorer farmers would tend to just because they can't usually access these water, they tend to transfer to different sources of land and therefore repeat the cycle all over again. This can also yield subsidence, which means that there's a softening of the land. And of course, saltwater intrusion. What is saltwater intrusion, you may ask? So if a well is built nearby some saltwater, like coastal areas, in oceans and seas, you can some of the salt water can actually get into the bedrock as well, and in turn contaminate the freshwater source. Thus, salt water intrudes into the freshwater source. Yeah. Why is it bad? Because you get less drinking water. We get less water to use to survive, for humans that is. Now, usually, fresh water from deeper aquifers are generally classified as non-renewable resources. Why? Because they take so long to recover. It's not like wind energy or solar power that can be instantly rejuvenated. No, it takes thousands of years to actually rejuvenate the water found in groundwater sources. So up next, we have your surface water. So what do we mean by surface water? It's usually fresh water that comes from precipitation or snow that falls across the land's surface and eventually drop themselves onto freshwater bodies and ultimately the ocean. Now usually, when we speak of surface water, they usually experience surface runoff. And this means that rainwater, the water that comes from rain, actually falls onto the ground and returns to the atmosphere via evaporation. So therefore, they don't necessarily infiltrate the ground. Because if they infiltrated the ground, they could turn into groundwater. So again, they just roll up back into the atmosphere. So again, just review your water cycle if you wanted to know the difference between infiltration and runoff. So we also actually access dams and reservoirs as well. So when we construct a dam, we build a structure across a river to control its flow. However, what happens is that we create an artificial lake called a reservoir that's usually behind the dam. Now the problem with this is that this tends to capture runoffs. So we have more water. That's not really a problem. That's a pro for us. That's a good thing for us. We can control floods. We can use it to generate electricity. We usually have enough water supply for irrigation. And of course, even our cities and towns. Now, the problem is that it can displace people and wildlife. Remember that there are some ancestral lands that are actually being taken by big companies so that they can construct dams. And that this tends to disrupt wildlife and the ecosystem itself. This can also bring about flooding because of the increased level of the reservoir, especially if we can't control it. And for people living near dams, usually they have a lot of trouble with flooding during the rainy season. Aside from that, we also have prolonged drought, and oftentimes blocked rivers often dry up. And for these rivers, oftentimes fish tend to use this for their breeding grounds. So if their rivers are blocked off, these fishes have no choice but to be extinct. So in a way, there's a lot of impact on how these rivers can affect wildlife and people. So just to show you guys, this is the Aral Sea back in 1989 versus recently in 2014. So in a way, it is constantly a problem how these bodies of water are constantly drying up because of climate change, because of global warming. So again, just to reiterate, fresh water is an irreplaceable resource that we are managing horribly, poorly. So, for the next video, we're going to talk about how we can do sustainable use of fresh water. So I hope you guys learned something new today, and I'll see you in the next video.